Welcome. Have you ever wondered why ships don't sink, no matter their size? We'll explain the science behind it in a simple and clear manner. The ability of a ship to float is based on two things: Archimedes' principle and the ship's design. About 2,000 years ago, a Greek mathematician named Archimedes discovered the physical concept that allows ships to float. Archimedes' principle can be explained quite simply. Let's imagine a bathtub filled with water. If we place a ball on top of the water, it will float. However, once we put the ball in the bathtub, some water will spill out, and that water will be displaced by the ball. Archimedes realized that any object resting on the water experiences an upward force opposite to gravity, known as hydrostatic force or pressure. On the other hand, the water that was displaced by the ball is called the ball's displacement. Archimedes concluded that the force pushing the ball upward and keeping it afloat is equal to the weight of the water displaced by the ball. Now, let's apply this concept to ships. For example, if a ship weighs 1,000 pounds, it will stay afloat as long as it displaces at least 1,000 pounds of water or more. In other words, it will float as long as the weight of the ship and the hydrostatic force pushing it upward are balanced. How do ships achieve this? Whether a ship floats or not depends on its shape and size. Ships are designed in a way that distributes their weight over a large area that is not entirely solid and is located at the bottom of the ship. Part of this large area is submerged in the water, and we call this area the hull. Inside this area, there are large empty spaces filled with air. This is what allows ships to float, as this large area makes the ship less dense than water. We can easily calculate density by dividing the weight of the ship by the volume occupied by the lower area of the ship. As long as the density of the ship is less than that of water, ships can be large, enormous, and gigantic, and they will float. Therefore, the design of a ship boils down to making it less dense than water. This allows us to determine the maximum load a ship can carry without sinking. If the ship is overloaded and becomes denser than water, it will sink. That's why it's crucial for ships not to suffer damage to their structure that could allow water to enter. If the ship fills with even a small amount of water, it will become denser and sink. In summary, ships displace a certain volume of water while floating. The water, being an incompressible fluid, pushes the ship upward, ensuring that ships will float as long as the weight of the water displaced is equal to or greater than the weight of the ship. This is achieved by distributing the weight of the ship over a large, mostly empty, hollow area, which is large enough to make the ship less dense than water. Remember that density equals the mass of the ship divided by the volume it occupies. The more volume the ship occupies, the less dense it will be, as the weight of the ship will be distributed over a larger area. If you enjoyed this video, please like, subscribe, share on social media, and leave your comments.